Hello, my name is Cody Rogers, and today I am going to do the evaluation of the circuit that I believe few of you at least have watched the sort of design of the circuit where I went through the design of it. But now I just wanted to do an eval of the circuit after I have successfully assembled it. I didn't record myself assembling it, and I thought I did. It appears I did not. But, anyways, I do have some data, stuff I can go through with you, and some graphs from the Analog Discovery 3 that I can also go through, and just some remarks on what went wrong and what I was surprised by. So, first things first is what went wrong that became immediately clear during the uh, assembling stage is that this guy here, my rectifier, MB10S-13, the footprint used actually had pins labeled wrong. So if we press E, go to footprint, you see what the difference is there. Well, first now you can see we got it lined up correctly. Yes, the numbering is flipped a bit. So, but you can see what I did to change. This is I fixed the issue now. But what it was before, this was 1, 2, 3, and then 4. What it was supposed to be was 1, 3, 2, 4. Now let's look just so that you can see on the data sheet. Yeah, open up the Shotwell viewer, rotate it so that it looks how it does. So this is on the data sheet itself. You can see pin 1, then pin 3, then pin 2, then pin 4. So I don't know why I should have checked it. I got burned basically by I believe I got the symbol and the footprint. I downloaded it from somewhere. It all came in one package. And I checked the measurements. If you look at the design, you can like the design video, you can see where I checked the measurements. I think probably at around the 15-minute mark or so, the 15-minute mark when I was placing components and checking the sizing. I actually went through quite a round of measuring this and trying to figure out if it was the right measurements, and eventually found one that worked. But still, I didn't check the pin number, in which you would have thought after having so much trouble finding the right one that I would have done that, but I didn't. So yeah, that's my mistake. Again, you know, always check your footprints, I guess, is the lesson. But anyways, let's move on. That wasn't that was more of an annoyance, not a interesting point. Um, will, however, just show what I ended up having to do. Basically, this. So I had to make sure they zoom in really closely there. That is actually an 8 pin, or like an 8 pin surface mount PCB that I just have laying around. Like it's a standard size. I forget what size it is, but it's for like 8 pin op amps and such. And I had it just laying around, so I did use it. It worked out for this one, luckily. And I just had to figure out what pin goes where. Then I used little alligator clips to connect it over here to where I had those test points made out, and it ended up working fine. Obviously, for the next version, it will be fixed. I am gonna go through what everything looked like when it was unloaded, as in all it was driving, all that power supply was driving the was the little LED on the board itself, which I can show you too, I guess. See, it did work. Just as a confirmation, it worked. See, the LED's on. Yay. So, here is my voltage. Here, let's set these up nice. Yeah, so we got the AC voltage after the transformer on my multimeter as 13.03 VAC. And then the voltage, the DC voltage, so after being rectified, was 15.61. Now, I don't know, those two numbers don't really match up very well. However, we'll see that I'll show you the unloaded Analog Discovery 3 output, and you'll see that the peak voltage was above 15.5 volts. So V peak was above 15.5 volts. So that lines up a bit better with what we see on the DC voltage. What's happening with the AC on my multimeter, it must be measuring VRMS, but still I've done the math, it doesn't work out that the DC or the peak voltage would be that. So, yeah. Anyways, let's go over here. And there we go. So that is the Analog Discovery 3 output when I don't have any load connected to it, per se. So you can see it goes from about, well, that is actually quite much more. I would say that's that's minus 1.5 there. That's 1.6. So I would say it's getting to about 1.7 there, and I'm using the times 10 probe of the Analog Discovery 3. So that would be about 17 volts peak to peak. So 17 volts peak to peak, which again lines up well over here. However, it still, like, if that's 17 volts and this VRMS, that should even be a bit higher. Like it's, so I don't know why my multimeter isn't reading that. Anyways, and this is something I want to point out because we'll talk about it more soon here. But you see this little flattening and distortion of my sine curve. We see that much more when we have a load on it. And yeah, that will be next. I think I'll just show you it fully loaded here. So I loaded it with some LEDs and some 560 ohm resistors. You see, this is when it's fully loaded. You'll see. I'm thinking I'm gonna include a short video of me adding and removing resistors. Either I'll include it here or I will make it as a short, like a YouTube short, just to show it, and then I'm not sure how I'll do that, but I did take a video of me adding and removing some resistors just to show the different current drop that I get when I do that. But this is with, I think it's 4 560 ohm resistors and 2 blue LEDs. And you can see it was drawn about 91 milliamps. The rated current for that transformer is 100 milliamps. And we saw quite a large distortion. Now, I was honestly quite baffled by why I was seeing this. Then I Googled, and I learned about transformer saturation. And I posted on this forum that I'm a part of through somebody who I reach out to for electronics tutoring called Contextual Electronics. And I got some nice advice there. They told me that that it isn't uncommon to see small transformers such as the one I was using to show this, because basically they are just little puny transformers and can't deal with the drawing that much current. So when the rated uh, the rated current is basically right near saturation. So yeah, but that was just a cool little thing that I saw. You can also see this is the DC on channel 1. Channel 2 is the AC after the transformer. Channel 1 is the DC. So you see we're rising. Would that be? That'd be pretty close to 9 volts there. So we're saying like this. So the Analog Discovery 3 says we're not quite reaching 10 volts. My multimeter says we do. Here, I'll show you what it says. So this is the DC voltage. So we're reaching 9 volts there. Then, now, yeah. What I'll do, I don't seem to have a photo of it, of the AC fully loaded there, but if we would get in, I think 10.3 or something volts. But here is the 2 for when we had 2 resistors instead of 4. So this was drawing about 61 milliamps. Like I would say this is more of a common load. So you wouldn't run it right to the max, which is something I didn't consider, I guess, before, was that that most of, like, when you're designing that, well, one, when you're designing it, you usually put a regulator after, which will be a future iteration, but that, like, yeah, I considered, like, oh, it's going to be putting out 10 volts, like, you know, at 50 milliamps, but no, that's not what happened. It's putting out about 11 volts AC, and it's run about 61 milliamps. And then that makes the DC go down to about 10.7 volts. It will also show, so you see what my setup was when I say that I had it loaded. It's this right here. So you see I had a little breadboard. I connected my 2 output wires to the breadboard, and then just had a couple resistors laying there, a few LEDs, just to give some current draw to it. Let's just look. I did in my evaluation of it. One second, I want to find where I did it in my. We're just going to do one at a time. This is when I was analyzing the voltage ripple that I saw on the DC end of it. So this is with 3 560 ohm resistors connected to the output and 2 LEDs connected to the output. I think at this point it was drawing. I didn't really comment on what it was drawing here for amperage, but we'll show when the next picture has the well, we have 5 resistors, 2 and 4 resistors, and the 4 resistors one, I know that it was drawn about 91 milliamps. So you see we go from, it's just a really tiny ripple in this case. It's not even, it's going like this would be 10 volts there. Then that would be 9 volts there. So we're going from about bottom of 9.5 volts to, oh, that's probably 9.9 volts, so 0.4 volts. Say. That's what I put down for the max load too. Here's the max. Or what I called the max load. It was 91 milliamps. You could load it more because it says that it should go 100 milliamps. But we went, and you can see it was at a lower overall voltage. Went at 8.8 volts up to 9.3 volts. So yeah, in my notes I said 9.3 volts and 8.9 volts. So, but it's still the very close to the same. Like when I'm doing it live here, I just said that about 0.5 volts. When I was first doing it was 0.4 volts, I said. So let's go look at this. Was at this would have been at really loaded. We go from at the top there, and that's about 8.8 volts. Goes down to 8.8 volts, so just a half volt ripple again. So that ripple is much smaller than what our design was calling for. We wanted to have a 1 volt ripple maximum, but I don't think we will try to cheap out anymore, or try to use a smaller capacitor or something. Mostly because it could be that particular capacitor I put in, maybe like because it had plus or minus 20%. So that particular capacitor might be plus 20%, right? So we don't want to make any assumptions based on just one build. Now, I just want to discuss what I'm planning to do later on with this circuit. I do want to make one, I want to have one set of revision boards ordered eventually. It won't be till about the middle of December. The reasoning for that is that will be when I am done or am completed chapter 11 of Learning the Art of Electronics. And I want to do this, I want to add a voltage regulator at the end of this circuit. So at this part, to take the voltage down from, so I think we were getting what, like 13 volts or something, 15 volts DC according to my multimeter at one point in the circuit, and I want to take that down and give a clean 9 volt regulation. So like I'll program it so that it puts out 9 volts like almost all the time out of the unregulated supply. So sometimes when we're not drawing much current from it, it will be wasting a lot of voltage, but then other times it will be not wasting much at all. That, and I'll make sure that I have this correct. Yeah, I think that is everything. I would just like to make a comment. I'd like to thank Chris Gamble for pointing out the importance of test points. It really became apparent in this circuit because I made a mistake with this guy here, again, the rectifier. And the only way that, well, I mean, I guess I could have tried to solder some things onto the little surface mount pads there or something, but it was much easier that I had these test points. Basically, we're at each pin of this rectifier, so I was able just to clip onto those test points with alligator clips and make everything work. Anyways, thank you for watching this video. I hope the audio is better than what you're used to. I have purchased a new microphone after many people have suggested it. And basically, I was getting frustrated with um, re-recording myself when I didn't look directly into my microphone or didn't stare directly at my webcam, and I had to re-record myself because or else you wouldn't hear me. Anyways, thank you for tuning in, and I hope to see you next time.